Okay, so today we're gonna start off by covering linear equations. And within this class, you will also see how linear equations are directly used, you know. So you can have a lot of equations. You can have something like ax plus b is equal to 0. That's a linear equation. You can have ax squared plus bx squared plus c equal to 0. That's a quadratic equation. And you can have something like ax cubed plus bx squared plus cx plus d. That's a cubic equation. All of those equations that I've listed so far, they are like polynomial equations,
Yes, sir.
So when we solve for x in the first one, we expect to have one solution. You know, we expect to have one solution. When we solve for on a quadratic, we expect to have two solutions. And the guy called Pascal came up with this idea. And, you know, when we solve in cubic, we expect to get 3 solutions. Okay, let's dive in. So pretty much linear equations, you would have met them. So it's something like someone giving you 2x plus, or maybe let me just do it simple first. X plus 2 is equal to 4. Now, the idea at which you solve this is that you want to isolate x as much as you can. So next to x at the moment, we have this guy. And what we have to think about, how do we get rid of that? You know, one thing that we do is to subtract it. You know, subtract it from this side and subtract it from this side. Are we happy? Now, if you focus on that idea, you realize that
yes, sir.
X has been isolated. Yes, S has been isolated, and our X value is indeed equal to 2. Are we happy? You can check if that's correct. So you check by saying, okay, you know what? My X is equal to 2. My equation was X plus 2 is equal to 4. Now, I want to check
if I
would substitute 2 here. Would I get 4? You know, boom, you get 4. So that's correct. Okay, cool. We can have another one where we have 2x plus 2 is equal to 16. And again, the objective, it is to isolate x. So you will see, if you want to isolate x on this side, you have to first get rid of that guy there, minus 2, minus 2. Once you've done that, you then have 2x is equal to 14. Now you have to further isolate x by getting rid of this 2 that's next to this x. And to do that, you would have to divide. Divide by 2, divide by 2.
Yes, sir.
So your x would be 7. Happy? Again, you can check if this is correct by noting that your x is equal to 7.
Yes, sir.
By noting your x is equal to 7, and therefore
then substitute to 7.
Yes. And then if you do that, that's 14 plus 2, that is 16. Boom, that's correct. Okay, cool. Can have another type of a problem where we have maybe x over 2 plus x over 3 is equal to 14, right? This one, I always just say, look at the denominator you know, multiply your denominators, that's 2 times 3, it's 6. And then multiply by that number that you get throughout the equation, right? So that would be x over 2 plus x over 3 is equal to 14. So what you would be basically doing, you'll be multiplying this by 6, that by 6, that by 6. That's the same as taking the equation, multiplying it, all of it by 6. Now what happens is that you get 6x divided by 2 plus 6x divided by 3 is equal to 14 times 6, 14 times 6, and that is 84. And then after you've done that, you can see that 6 and 2 can divide, you'll get 3x, plus this side you'll get 2x, and that would give you 84. And therefore these will combine to give you 5x is equal to 84. And again, you can try to isolate x by dividing by 5, both sides. And then your x would be equal to 84 over 5. Again, you can check this one, right? So you can check this. If you say 6 times...
Sorry, sir. I'm sorry, sir.
Yes.
I'm sorry to do this to you. Can you please go from the previous one? Oh, yeah, le fraction.
Yes.
Can you please go through that again? I didn't get that.
So what I do is that I think I would rather do it differently. Can I do it differently so I won't check this one?
No problem.
I'll just do a different example. So suppose that someone gives you, let's say now it's 2x divided by 4 plus 3x divided by 2. That's equal to maybe 1 over 4, right? You basically look at the denominators that are involved. They must be unique. Like in this case, I can't say 4 times 2 times 4. Each number must be represented once. So this is going to be just 4 times 2.
Okay.
That's fine. So that's 8. So you just multiply your whole entire equation with that 8.
Yeah.
That's a better thought process of doing it. Other people would want to do it differently, but this is the better thought process, or maybe this is a better way of simplifying what you're physically doing. So you multiply by 8 here, multiply by 8 here, and multiply by 8. And that's effectively you multiplying your function by 8. So after you've done after you've done that, you're then going to have 16x divided by 4 plus, I think that's 24x divided by 2 is equal to 8 divided by 4. Are we happy?
Yes.
And then what you will have here, this is just going to be 4x plus, this is going to be 12x, and that would give you 2. These ones combine to give you 16x is equal to 2. So your x would be equal to 1 over 16, which is 1 over
16.
Okay, are we happy?
Yes, sir, very happy.
Okay, cool. Now, that's it about equations. I'm happy that you are able to sort of like see that you can also check them. And now I'll start doing linear equations. Can I do linear equations? Okay. Sorry, linear functions. Sorry. Oh, sorry. Linear functions. So functions, you have, for a linear function, you have f of x is equal to ax plus bx. plus b. You know, other people like to write it differently. They like to writing it as f of x is equal to mx plus c.
C.
Now, this guy over here is our gradient. Gradient means the same idea as the magnitude of your slope. You know how steep something is? When you're doing calculus later, you would interact with this more closely because you would,
Yes, sir.
you would be able to look at the function and you'd be like, yeah, here, this is where the function is steepest the most. This other guy is called, what is this again? This is our y-intercept. Now, the way we look at graphs, there are three things that we have to master for each and every graph. You need to be able to draw the graph.
Yeah.
To be able to find the equation of a graph. But thirdly, you need to interpret it. Now, the way I'll do it is that I will just focus on the first two. I'll focus on drawing and finding the equation, right? Those are the only ones that I'll focus on. And then later on, I will focus on interpretation where we just interpret all of the graphs, look at some of the things. Okay, anyway, so now it looks like we're gonna start by drawing them. So let's go through that. Examples. So we're gonna have one, f of x is equal to, let's say 2x plus 2 to draw. And the second one would be g of x is equal to minus 2x minus 2. And then we will then have the third one where x is equal to 2x. The fourth one where y is equal to 4. And the fifth one where h of x is equal to minus half x minus 2. I'll make that plus 2. Okay, anyway, these are the examples that we're going to be going over. We're going to be looking at how to draw these guys. And yeah. Drawing these guys is quite very easy. Now, when you draw functions or maybe a line, how many points do you need at minimum?
Your y-axis, your x-axis. I think 2 because you're not yet at the turning point. So class draw a linear function. I think 2, yeah, 2.
Yes, we only need 2 points, and those points would be our special points, our y-intercept, and our x-intercept.
Intercept, yes.
Yes. Okay, cool. Let's go ahead and try to do the first one. So we have f of x is equal to 2x plus 2. Now, okay, there we go. So we're going to start with our y-inter. That happens, the y-intercept happens when x is equal to 0, right?
Yes.
And oh, sorry. Just wanted to draw some. Let me see if I can try to use a different way. Okay. Anyway, I'm going to start with our y-intercept, and then we're going to come with our x-intercept. That also happens when y is equal to 0, so they are similar. And boom, we're going to go and do those guys. Now that's our function. we want x to be 0. So we're gonna, everywhere we see 0, we will substitute 0. And then for x, everywhere where we see x, we'll substitute 0. Right.
Yes,
You
sir.
will see that would be 2. So when x was 0, you got 2. Those are your coordinates for your x-intercept.
Yes.
Now, I want to just mention something that I said earlier. I said that a linear function is given by mx plus c. So if you will always substitute x is equal to 0 for your y-intercept, it means that this would be 0 and this whole entire term will always go away. And the term that you will always have, it's that term. Hence, that term is referred to as a y-intercept.
Y-intercept, yeah.
Okay, anyway, let's come to our x-intercept. You have f of x, You have f of x is equal to 2x plus 2. But, you know, we have to substitute y is equal to 0. And so this must be 0, right? And you see now, that's why I had to first do linear equations, because now when you're trying to find your x-intercept, you need to know how to solve a linear equation, because at this point we are solving a linear equation. Do you see that?
Yes.
So to solve this, we're gonna have -2, and then we're gonna have 2x, and then we're gonna divide both sides by 2, and therefore our x would be equal to -1. I just like to write it as x is equal to -1. But again, to get the coordinates, we got our x is equal to -1 when we substituted y is equal to 0. So those are our coordinates. Now
Yes,
we're
sir.
just using these coordinates to draw. Right, so so this is going to be our 2, and roughly here this is going to be our -1, and we can draw our function just like that. Now I'm not very strict about your scale, but just make sure that relatively 2 is bigger than -1 in a proportion. But I'm very strict about you labeling your graph properly. Your y-intercept must be properly labeled. Your function must be labeled that this is f of x. Because from time to time, you could be drawing quite a number of functions in the same Cartesian plane. So it's important that you sort of like make sure that you do things properly. So the second graph, do you see the second graph is not really different from the one that we did? So that's your homework.
Okay.
And then I'll draw the third and the fourth one.
Okay. Sir, can I quickly write that down? Okanye,
What would you like to write down?
la homework yam kalo.
Yes. Are we happy?
Yes, sir, you can go on. Thank you.
Okay. Okay, now we have to draw this. You can see this one, you can't really think about the x-intercept and the y-intercept, you know. So we probably just go to the drawing board and put our Cartesian plane, just prepare things while we are still confused as to how do we draw that. Y is equal to that. Okay, that's fine. Basically, this function says I am 2 in terms of x, and this function doesn't really care what y is. So this function is it's 2, and it goes all the way like that. And it's like that. You know, this function is not really easy to justify why it looks like this, but the other function is quite easy to justify why it looks the way it would look like. Okay, it's fine. Are you happy?
Yes, sir.
Okay. lastly, from my side, in terms of drawing these functions, I will draw the following function. Y is equal to 4. And this one is more nice to explain. And you can sort of like say, okay, this is the function y is equal to 4. It continues like that. It's y is equal to 4, and that's my y-axis, and that's my x-axis. Now I'll explain that in a moment of why this function looks like this. Just want to say one more thing and say number 5 would be your homework.
Thank you, sir.
Now let's go back. Let's talk about the gradient. Now, the gradient is one of the things that you're going to speak a lot on. Calculus is just based on a gradient as well. The whole entire chapter. But anyway, gradient. So gradient is given or symbolized by m, and it's given as the change in y over the change in x, which is given by y2 minus y1 divided by x2 minus x1. Now, we need to be able to know how to calculate the gradient. And as I've said, gradient is the slope, but we need to be able how to calculate gradient. So let's have some few examples of how to calculate of gradient. I'll have one where I ask you to calculate the gradient between 2 and 4, and 4 and probably 8, right? Then I will ask you to calculate gradient between -2 and 6, and 4, oh, sorry, 5 and 6. And then where I want you to calculate gradient between I like 1 and -2, and 1 and 5. Cool. Now I just realized that for us to be able, I want us to calculate this gradient here. So I don't want us to move down. So I'll rather move. Okay, let's start with the first one. So the gradient would still be given by change in y divided by change in x, which is y2 minus y1 divided by x2 minus x1. Now, I want you, in your mind, when you deal with these problems and you have 2 points to calculate gradient of, to note that, I'm going to make this my gradient, the first set of coordinates. This I'll make it the second set of coordinates. And that would actually means that this would be x1 and this would be y1. This would be x2 and this would be y2. And then you can then calculate so that you don't make an error. So here you can say 8, you can clearly just say 8 minus 4 divided by 4 minus 2. And that would give you 4 over 2. And the gradient is 2. Right. Now,
yes, sir.
If your gradient, okay, maybe let me just, maybe that's not the point that I wanted to say. I'll say that separately. Okay, so, and then let's calculate what's going on here. I'm gonna do the same thing. By now, I'm not going to do what I did there with the coordinates. You should know. You should have.
Yeah.
Did I just change the color of these now? So this is going to be the gradient is equal to change in y over the change in x, which is y2 minus y1 divided by x2 minus x1. And that would give you what? 6 minus 6 divided by 5 minus
5
2.
minus 2.
That would be 0 divided by 7. Boom.
7.
Our gradient is 0. Okay. Okay, let's see. Let's go forward. Next one is the change in y over the change in x. We're given this would be y2 minus y1. This would be divided by x2 minus x1. And that would be 5 minus 2 divided by 1 minus 1.
1 minus 1.
That's 7 over 0.
0.
That is undefined. It's undefined. Okay, just realized that I should give you a last set. Let's say you have 1 and 1. And the second set is -4 and -4. No, -4 and 4, like that. Yes, so let's calculate the gradient here. The gradient would be change in y over change in x is equal to y2 minus y1 divided by x2 minus x1. So this would be 4 minus 1 divided by
1
minus 4
-4
minus 1.
minus 1. 3 over
-5.
-5.
Okay, cool. Now I want us to look closely what's happening here. For the first one, if we were to draw like small graphs of these, just looking at the points, we have 2 and 4. 2 and 4 is about here. And we have 4 and 8. 4 and 8, it's about here. Right? Now, this graph is not accurate. I don't want you to look at, I just want you to look at the fact that your graph is like that, not where it cuts and whatever. So you can see your graph looks like that when your gradient is positive. Like it's like falling to the right. You see,
yeah,
it's leaning more to the right. Now, I want us to look at what's happening here. Here, no, we're not gonna have very nice space to draw this. But here, you have 5 and 6, which is somewhere there, and -2 and 6. So here, you have a flat line. Do you see that?
yes.
Because the same, you have the same y value here. So you have a flat
Okay,
line.
okay.
So do you see
Yeah.
that you get a flat line when your gradient is 0? So just to go back to some of the problems that we have looked at so far, we had a problem where we had to draw y is equal to 4. So this is where y was equal to 4. So I can argue that for this flat line, what we actually have, we have y is equal to mx plus c. And we do have our gradient, it's there, it's just that it's 0. And we then have c, which is 4. So that's why that line looks like that.
Like the yes.
Okay, cool. Yes, that's that with number 2. And number 3, we have something that's undefined. Let's look at how it actually looks like. You know, we have the same one. Also, we have something like this point there and this point there. So the x values are the same. This function is looking up, and you know we have the same x values. So this term over here goes to 0, and then we end up with undefined. So this function end up being given by x is equal to whatever value that appears
Value.
twice. You know, it's 1 in this case.
Yes.
And then this one, if we were to just quickly plot it, just roughly, we'll find 1 and 1 somewhere here, and -4 and 4. So it's gonna be falling to the left, if I may say. Right. That's for a negative gradient. Do we see that?
Okay. Yeah.
Okay, cool. Let's have a little cute summary. Oh, sorry. Summary just for the stuff that we've done so far. If your gradient is greater than 0, your function would be like falling to the right. If your gradient is less than 0, your function would be falling to the left.
To the left.
If the gradient is 0, you're gonna have a flat line like that. If your gradient is undefined, you're gonna have a vertical up line like that. That's our little cute summary. Okay.
Okay. Yes, sir.
Now let's look at finding the equations of graphs. Now this I would consistently teach it because, you know, there are many ways that they can give you these things. I want you to note something. If you have 2 lines that are parallel, like that, the gradient of this line is M1, the gradient of this one is M2, their gradients would be equal.
Okay.
Makes sense, right? They are inclined at
Yeah.
the same angle and
Yes.
yeah. If you have lines that are perpendicular, meaning that they meet at 90 degrees,
Chris.
and you have this gradient is, you have this gradient is M1 and you have this gradient is M2.
M2.
When you take M1 and you multiply with M2, you should get -1.
Yes.
Okay, cool. So now let's talk about finding equations of, so to find equations of a graph, you need 2 points. You can either have 2 points or you can either have a gradient and a point. Now, as you advance in mathematics, you will find that there are many ways that they can give you this gradient. Many ways. And then you'll just use the other point. But anyway, I think for now, I will give you maybe 2 equations, 3. I'll give you, I'll give you 3 graphs to sort of like, you know, try like as an example for this.
Okay.
Okay, I'll actually give you 2 at the moment. I'll give you just an equation that's like that, where you have, let me say that's like that. Give you that's f of x, and it has a point there that is 2 and 7. And I'll give you another point there that is -3 and -4. -2. Anyway, I'll give you that. On the other side, I will give you a graph that looks like this. And I'll just give you 1 point. And I will say that that point is 2. However, this has a line that runs like that with the gradient of 2, right? So now we're going to try to find the equations for these graphs. So remember the equations to start off with, they are given by f of x is equal to mx plus c. Now, it is suggested by the equation that we need to find what m is, what c is, right? C would normally be the point that's here, but we don't have any point there.
Okay.
So it looks like we're gonna have to first calculate our gradient, which we know how to do.
Yeah.
It's y2 minus y1 divided by x2
over x.
You wanna calculate that numerically and let me know what it is?
Okay. 7, that's gonna be -2. Nine over 5, yeah.
Yes. Are we happy with that answer in the sense that do we see that the graph is falling more to the right? So the gradient must be positive and we are getting a gradient that's
Positive, yeah.
So we should generally be happy. So now we have made progress in our function. Now our function looks like 9 over 5 x plus c. So we just have to find c now. Now to find c, we substitute one point that falls on the graph. You can choose 2 and 7, or you can choose -3 and -2.
-2.
Choose 2 and 7 and substitute that point and calculate what would be your C. I will choose -2 and -3. Okay, so I'll choose,
Okay.
so I'll choose -3 and -2. And to substitute it, remember that this point is y, this is x. So to substitute it, you sort of like put this here, and then you put the -2 in the y place, and you put the -3 in the x place, and then you solve for c. Yes. So you can do it as well with the other coordinates, and then we'll just confirm at the end.
I was literally sleeping, bro. Akafika derivatives.
Okay, so just, yeah, I'll give you some time to just go through that. Hope this is what I got. Just see if you substitute those points, you get the same thing. Okay, are you winning? Are we winning, Luvuyo? Okay, Luvuyo. Okay. I'll start doing the second one.
Sorry, sir. Did you calculate? I'm getting there.
Oh, okay, okay.
Sorry. Oh my God, what is? Yeah, it's 9 over. 9 times 2. Okay, I am gonna get something else up. I'm not supposed to get this, but I'm gonna get something else.
Okay, I'm just looking at the time. Please finish that and send it to me. At least you see the.
Okay.
I'll do the last
Oh.
one now.
Okay, yes, sir. I'm sure.
Again, this is a linear equation. This is much more.
Yes.
simple. It's mx plus c. So that's the form that we know. However, we want the gradient. Now, the gradient here is the gradient of the how do I say this? It's the gradient of the line that is orange. So we can say, if you look at M orange and you times it with M red, you should get -1 because those lines are perpendicular. Maybe I didn't say that, but like, yeah, those lines are perpendicular. Now, if you consider that, you can, if M, you are looking for M0 and you are given M red, you get -1. You know, you can divide both sides by 2. So M0 would be -1 over 2. We're getting a negative gradient and we have, you know, the right shape for a negative gradient. So we can go straight and be like, f of x is equal to -1 over 2x plus c. Now we have to find c. But remember what I said c was? C is exactly that point over there. And this time around, we are given that point. So we can just put it there. So our function would be -1 over 2x plus 2. And we are done. Okay, are we happy? I'm so sorry, something happened to my network.
Yeah, I understand.
Where did I lose you?
And when screen, I'll share the screen.
Oh, yes, let me just try to do that. I didn't even realize I carried on to write. Just give me a second.
Okay, no problem.
Yes, did you get all that?
Yes.
Yes, so what I was saying is that, yes, we are happy at this point. So I was basically saying that we've done linear equations and we've done linear functions. And we'll just carry on like that, where we do linear equations, linear functions, quadratic equations, quadratic functions, exponential equations, exponential functions, hyperbola are on their own. Okay.
Okay, sir.
That's it for me. I will see you tomorrow, same time.
Okay, I'm gonna send you the answer of this, ne?
Yes, just send it together with your homework.
Okay, no problem. Okay.
Sure.
Uzaiposta must video go YouTube, ne?
Yes.
Okay, I'm gonna check it again. Okay.
Okay, sure. Cheers.
Thank you, sir.
You're welcome. Thank you. Bye.